Hello everyone. Welcome yet again to another session on 12th Chemistry, Chapter 2, Lecture 7 and 8, Solutions. And the topic of discussion today is solubility of a gas in a liquid. That forms lecture number 8. So mistakenly in the earlier lecture I have written it as lecture 6. It is actually lecture 7. So this is lecture 8. This is lecture 7 and 8. So that will be the continuation. Sorry for my mistake in the previous video. So it was lecture number 7. I have written lecture number 6 actually. So lecture number 6 is a problem solving session for your reference. Now this is a very small topic I am discussing in this video. Now let us see this. So this goes like this. Almost all the gases are soluble in water, but the extent of dissolution is different for different gases. Okay. The solubility of any gas, in particular liquid, is the volume of the gas. The volume of the gas should be measured in centimeter cube. That's the volume measurement in centimeter cube. That can be dissolved in 1 cc or 1 ml. 1 cc is equal to 1 ml. 1 cc means 1 centimeter cube, 1 ml of the liquid to form the unsaturated solution at certain temperature and at a certain pressure of 1 atmosphere. Okay. So that is the definition. What are the factors that affect the solubility of a gas? So that is the nature of the gas, that is solute, and the solvent, that is the liquid, and the temperature as well as pressure. So those are the 3 factors. Describe how the nature of the gas and the nature of the liquid will affect the solubility of a gas in a liquid. The solubility of a gas in a liquid depends upon the interactions of the gas with the liquid, that is solute-solvent interactions. For a given solvent, the solubility of different gases would be different. So for example, you can take like gases like hydrogen, oxygen, nitrogen and helium, etc. dissolve in water to a very small extent. But the gases like ammonia, HCl, SO2, etc. are highly soluble in water. So let's go to the next question. So describe how temperature will affect the solubility of a gas. This is a very important question. The solubility of a gas decreases. Solubility of a gas decreases with the increase in the temperature. When there is a gas dissolved in a liquid upon heating, some gas is usually expelled out of the solution. And that gas goes out of the solution. That is a very general thing which we all, okay. So when you start boiling Coca-Cola or something, you can see that the carbon dioxide bubbles coming out of it. So that's a very known thing. Okay. So dissolution of a gas in a liquid is an exothermic reaction. Okay. So you can see that the heat is evolved when a gas is dissolved in a liquid. So as per the Le-Chatelier principle, when the increase of temperature, as per the Le-Chatelier principles, with the increase in the temperature, the solubility of gas would increase. Okay, for exothermic reactions, it follows that. So it is like gas plus solvent. It dissolves, the gas dissolves in solvent to form the gaseous solution, and then there is a evolution of heat. So the equilibrium shifts towards a backward direction. So this is how the temperature will affect the dissolution of a gas in a liquid. Describe the effect of pressure on the solubility of a gas in a liquid. This is the next question. This is also a very important question. The solubility of a gas increases with the increase in the pressure. Assume that the gas liquid system is at dynamic equilibrium at a pressure of P and temperature T as shown below. So I have considered situations. That is, situation 1 is that here is a piston like this, and a weight W1 is being put, and it applies a pressure of P1, and the gas is in dynamic equilibrium with the liquid, and some gas is dissolved in the liquid. The red dots will denote it's just a representation of the gas dissolving inside the liquid. So the red dots will show this. And some gas is over and above the liquid, okay? And now when I increase the pressure to P2, so that's the situation P2 is greater than P1, the gas molecules will come closer. So that means that you increase the pressure, the number of gas molecules per unit volume will start increasing. And hence you can see more dissolution of the gas inside inside the liquid in order to establish a new dynamic equilibrium. So that is the idea which is discussed over here. So the concentration of the dissolved gas is proportional to the pressure applied upon the solution. When the system is at a pressure of P1, I consider the initial situation, and the temperature T. The two situations are maintained at a fixed temperature. Okay. And initially at a dynamic equilibrium, the rate of gaseous particles entering and leaving the solution will be the same. So that's what the dynamic equilibrium is all. Now on increasing the pressure over the solution phase by compressing the gas to a smaller volume, there is an increase in the number of gaseous particles per unit volume over the solution, and also the rate at which the gaseous particles are striking the surface of the solution to enter it. That factor is also increasing. So the gaseous molecule starts hitting the surface of the solution, and hence once it starts hitting the surface, the dissolution increases. So this process will establish a new dynamic equilibrium. The solubility of a gas will increase until a new dynamic equilibrium, new equilibrium is reached, resulting the increase in the pressure of the gas above the solution, and thus its solubility will increase. So that's the idea, and that's it for this video. And so the basic idea is that what I represented here is that you can see that once the gas molecules comes closer, they start interacting with the liquid surface, and then you can see more dissolution of the gas. That is a representation of more red dots compared to here. Okay, so the more gas has dissolved once I increase the pressure P2. How do I increase the pressure? By applying the weights over the piston. I extract two weights, W2, W3. I brought in here, by which I increase the pressure. So that's it for this video, guys, and thanks for watching the video, and hope you like it, share it, and subscribe the channel. Thank you.